Ladies and gentlemen, in this video cast, I'm going to show you how to find velocity from a position versus time graph. This will support you in particular on one step of your bubble lab. However, this is also information that you will be tested over. So please use this to help you complete the analysis portion of your bubble lab. But as I stated, you will also be tested on the ability to do this. So let's look at this example. If we have a graph that looks like this, so we're going to begin by selecting 2 points that you can estimate the coordinates for that are as far apart as possible on the line. So let's begin by selecting the coordinates. So here's an example of a coordinate that you would not want to select. This is clearly occurring at 8 seconds, but it's difficult to tell exactly what the coordinate would be on the x-axis. It might be about 52, but it's hard to say. Here's another one that's an example of a coordinate that you would not want to choose. It is at about 16 seconds. However, we'd have to estimate it at about 85. And the last one that is a poor example is at about 30 seconds. The coordinate appears to be about 148 or 149. But again, none of these are particularly good choices. So let's go on now to some that are better choices. So we're going to choose some points where we can more accurately read the x value. So if we begin again, we want to make sure that we're choosing points that are as far apart as possible. That makes our velocity calculation more reliable and more accurate. So I want to start at t equals 0 and determine whether or not I can read the data point off for that. And I can. If you couldn't read it at x equals 0, if it was somewhere between one of the marked points, then you would move over to another point. You don't always begin at x equals 0, but it appears that we're able to choose that point. So let's go ahead and choose that point. So the coordinates at the small circle that I just made are 0 seconds, 20 meters. And that is clearly our ti, xi coordinate. So we're going to record that in the box over here so that we're keeping track of the points that we're going to use in our velocity calculation. Now we're going to look for a point that's as far away as possible along the line and yet has coordinates that are easy to read. So I suggest that the point that was just highlighted is the best point. And that point is at the position 24 seconds, 120 meters. And that will be our TF, XF point. So that is now recorded over in the box on the right. So now we're ready to use the velocity formula. Now that we have these very clearly marked and we know how to select the correct one to put into this equation. So let's move now to using the velocity equation. You want to make sure that you have a model where you've stretched out the operations and leave holes for the values that you need to drop in. So as we do that, clearly the XF value is the one we need to begin with. So as we read across here, the XF value is 120 meters. So that's the first value in the numerator. Then we subtract from that the XI value, the initial X position. So in this case, that's 20 meters. Then we go to the denominator, and the first term in the denominator will be the final time. So TF is 24 seconds. That will appear here. And then we subtract from that the initial time, which in this case is 0 seconds. So when we do that math, we find that the value that we're going to have to solve is 120 meters divided by 24 seconds. So when we do that math, we find that the velocity of the item shown on this graph, according to the line that's plotted, its velocity is a positive 5 meters per second.